In this video, we're looking at conditional probability. So this is probability where some condition or constraint has been placed. I'm going to look initially at what this looks like in a Venn diagram. So in this Venn diagram, we have event A on the left-hand side with the blue circle and event B on the right-hand side with the green circle. And the intersection of these two events is where A and B both occur. Now, if we are looking at the probability of A given B, which is what this notation represents, then what it's saying is the probability of A given that B has occurred. So we know for certain that the event has happened within this green circle. So to find this probability, we put the probability of A and B, which is this dark grey section in the intersection, over the probability of B. We don't have to worry about anything in the white sections because they definitely have not occurred. We have been told given B has occurred. So what we're going to do is look at a question and see how this is applied within the question. This is where literacy plays a very important part within mathematics. The question is, a zoo has a probability of 80% of having an article published in the newspaper when there is a birth of a baby animal. When there is no birth, the zoo only has a probability of 30% of having an article published. The probability of the zoo having an animal born at any one time is 40%. Find the percentage probability that a baby animal was born given that an article was published. So using our literacy skills, we need to draw out the information that is required. I'm going to put this information into a tree diagram, where B represents a baby animal being born and A represents an article being published in the newspaper. So the probability of the zoo having an animal born at any one time is 40%. So that gives us a decimal of 0.4. Now to find the probability of no baby animal being born, we find the complement, which gives us a value of 0.6. So 0.4 plus 0.6 is equal to 1. Now, why I chose to put the probability of the baby animal being born or not born first was because there was no constraint or condition placed on that probability. Whereas, as you will see with the articles being published, there is a condition on those probabilities. A zoo has a probability of 80% of having an article published in the newspaper when there is the birth of a baby animal. So this gives us a value of 0.8. And as you can see, we're looking at the branch where a baby animal was born because that meets our condition. Now the probability of there being no article published, even when a baby animal is born, we find the complement, which gives us 0.2. Now, if we to look at when there is no birth, the zoo has only a probability of 30% of having an article published, which gives us a value of 0.3. To find the probability that no article is printed when no baby animal is born, we find the complement, which is 0.7. We are asked to find the percentage probability that a baby animal was born given that an article was published. So this is the probability of B given A. Now, as we looked at, that is the probability of B and A, or B intersecting A, over the probability of A. Now, from the probability tree, we can find the probability of a baby animal being born and an article being published by multiplying the probability of B times by the probability of A, which gives us 0.4 times 0.8, or 0.32. To find the probability of an article being published, we're going to find the probability of these two branches. So that will give us 0.4 times 0.8 plus 0.6 times 0.3, which gives us a total of 0.5. To find the probability of B given A, we're now going to substitute those values in, which will give us 0.32 divided by 0.5, which is 0.64. We need to write that as a percentage because the question asks us to find the percentage probability. So that will give us 64%. So the probability that an animal was born, given that an article was published, is 64%. I hope you found this helpful.